In the last episode, Rover drove into a wall. I don't know how much you guys could tell from my expression what that meant to me, but I had a bit of a hard time with it. It was difficult to see that we're still so far from where I want to be. That being said, for the past couple of days, I've been thinking through exactly how I want to make Rover's code more robust and really implement a semi-autonomous operation, improving the way in which his code works in conjunction with the web server so that we can provide him some kind of baseline instructions that he can use in operating himself remotely. I've made progress in the meantime, so let me tell you some of the challenges that I've run into and where we're heading next, because that's exciting. So with Rover's build, I'm always pushing ahead and want to get to the next thing that's actually fun and something that's kind of worthwhile to actually show you guys on video. Unfortunately, there's a lot of stuff that happens that you guys probably won't find all that interesting, or at least some of you won't. For example, the relay manager. And if you're not familiar with relays, basically what they allow us to do is to turn on and off different components within Rover. And that's important for a few reasons, but one of the big ones is power management. Rover's got 2 big batteries. The more things that we can flip off when we're not using them, the longer Rover will last. So what we're looking at here are the Arduino Uno sketch here on the left and the relay manager sketch that I put together. And I'm going to include this on Rover's website for anyone who's interested, because I found, and I'll include the reference link as well to the code that somebody came up with, because their solution was far better than mine. The reason why I had to tackle this at this point was because the way I was flipping the switches, the relays, was very inefficient. I had no insight whether or not a particular switch was already, a relay was already flipped. So when I was going to flip, for example, the relays 1 through 3, I didn't know whether or not relay number 3 was already flipped or not. And the new relay manager basically gives us the ability to evaluate which relays are on, which relays are off, and individually flip relay 3, for example, without affecting any of the other relays. And that's pretty important. It also gives us the ability to have feedback. Go on the web server and find out which relays are on, which relays are off.
So in an earlier episode, I showed you guys that we had new status features here for Rover when he's off, online, offline, and kind of what operating mode he's in. And basically what we've done here is added a new Rover status sub-tab, which will have more of the details here, just as we talked about with the relays, for example. And of course, allow the web server to make use of that information in how he operates and what commands he executes and when he executes them.
So we're back on the command center, and I'm going to run a quick command. You'll see that we've got far fewer programs in the list here, and you'll find out why in a second. So I've just selected the all-wheel straight command. I'm going to send that over to Rover. And we see him executing the wheel straightening command at each of the 4 corners. And finally the rear left. And there we go.
And here we are on the Command Center at Rover's activity feed for today, Sunday, and we see these 4 servo rotation commands here, all executed. And of course, we've seen that many times before, but the difference now is these are coming from not hard-coded values for those programs, but rather a dedicated section on Rover's website to which we can add, remove, edit these programs. So for example, if we wanted to, let's say, here's the all-wheel straight command that we just ran. If we said, for example, that we wanted to add another command to that program, we could simply select the program as we have here, go to the edit. We can set, for example, the servos to neutral, send that over. And now if we go back here, we do a refresh, we now see that we've got 5 commands total, and the 5th command being the neutral positioning of the front left servo.
You might be wondering why it is that I had to tackle that. It seems unnecessary. It's very necessary, because the next thing that comes after that is what I'm going to call events. We need the ability for Rover to check in with the web server, and as he already does with his logs, and say, for example, that he has run into an obstacle at his forward sensor. Then the web server could say, well, because that event has occurred, let's check to see if we have an event action. I'm not sure what the jargon to use here is. Let's see if we have some action that corresponds to that event. And if we do, then let's add that dynamically to Rover's list of upcoming commands for him to execute as a result of what just happened. For that to all be possible, we need the ability to dynamically add and remove items from ROVer's list of commands to execute.
Back on ROVer's activity log, you can see that we've been doing all sorts of testing. Anytime we do anything, it gets logged, whether that's us submitting a command over to ROVer, a program or a command to ROVer, or ROVer reporting something in his logs, it gets put into the activity feed. And that's for us to not only have a record of everything that's happening, especially when we have more operators involved, not just me, Geppetto, and ROVer, of course, himself. It's going to help us figure out who did what and when and all that stuff. Specifically in regards to what we're handling today, you can see that we've got program additions, program creations, and event actions being added. And the icon that we're using for this is this sort of split thing, because essentially an event action is handling an if-then situation. So if something happens within ROVer, then what should happen next? So if we move over to the program and events section, here we see the programs list that we saw a moment ago. If we flip over to the events, and of course this is still a work in progress, the idea here is that for each type of event that can happen, and these are the events that we currently have within ROVer's programming, and they're coded with this kind of 10,000 and increment values, then what should happen next? So if we bring up ROVer's command center, so if we say, for example, that we want the all-wheel straight program to be associated with ROVer's 10,001 kind of obstacle forward sensor situation, which of course is not the case, but just for the time being. So we'll send that over. And then after that, we want him to rotate his servos into a spin orientation. So we'll send that over to the same event code. Now if we go back to the programs and events section and flip over to the events tab, we can see that these have been added. And the idea here is that if this code gets logged by ROVer, then the web server will check to see if there's anything in this list. And then if there is, as there is right now, those items will get copied over to the activity feed and will appear as pending. Just the same as if we went to the command center and took that same all-wheel straight program and submitted it to ROVer, it would appear within ROVer's activity feed as pending, just like it is here, and then ROVer would execute one by one.
So I'm really excited about everything that's coming together because the infrastructure that this represents is really powerful. So unfortunately, I didn't get quite far enough along today in order to show this stuff in action. Hopefully tomorrow we'll be able to see an initial testing of this dynamic response to ROVer's logged action codes. And what we'll do is we'll run a test where ROVer logs an event at his forward sensors and then checks with the web server to see what is in those event actions lists that we just saw a moment ago on the command center, and then have those executed one by one within ROVer's regular protocol. So here's a quick sketch that I did up. And what I'm trying to demonstrate is a situation where we don't want ROVer to take the first turn, for example, when running down a hallway. We want him to take some other turn, for example, the second turn. When a particular event happens, such as the distance to his right sensor increases, indicating a hallway to his right, we want him to skip the first and then go to the second. So the hallway example is really just one case, and I'm sure you can appreciate that there's many different situations where that sort of logic can come into play. And I think I have a solution around how to program that into the command center such that ROVer will have the options, and we'll have the option to communicate which sequence of events we want him to do in response to whichever event occurs. ROVer stares down my hallway all day long. It's his nemesis. With what we're setting up right now in the command center in the cloud, it's going to give ROVer the ability to autonomously navigate situations like the hallway. where he has to do different things depending on which order, which sequence of events occur. If you're excited to see how it all comes together, join us next time. Use the comments down below on YouTube or over on ROVer's site. We'd love to hear from you. Questions, comments, suggestions. Give us a thumbs up. Subscribe to get notified of the next episode, and we'll see you guys next time. Cheers.